So we're going to talk about parabolas. So you want your notes open to the parabolas notes, which is 571. We talked the first day about kind of what a parabola is. And a parabola looks the same, but it might open up different ways throughout. But it's going to kind of look like a U. Okay? When we cut that conic section in, there it is. When we cut our conic section at an angle that goes through the base, that's when we form that parabola. So we've got our conic sections here. We've talked about our circle that's formed by cutting the what is this thing called? The cone. Parallel to the base. Okay, that was our circle, and now we're talking about our parabola, which is that face that's made when you cut that conic section at an angle through the base. Okay, so that's what we're looking at today. Parabola, what is it? It is a curve where any point is at equal distance from the focus and directrix. I would highlight that right there because that's how we are going to derive the equation. Okay, so the big thing that we're talking about here is not necessarily getting into parabolas a ton, but it's understanding and deriving the equation of them. Okay, so that's going to be our big idea for today. Since it says a curve where any point is an equal distance from the focus and the directrix, we're going to be able to take the distance from any point to the focus and the distance from any point to the directrix and set them equal to each other, and then make an equation out of it. Okay, we're going to get to that. Just giving you some ideas. To get there, you have to know what the focus and the directrix is. Okay, the focus is a fixed point. So in this example here, this is the focus. Okay, if you've ever opened up a flashlight and looked in the inside of it, okay, there's a metal frame that's kind of cupped that's in there, and then the light bulb sits right above the metal frame, okay, and then it shines out from there because that allows the light to be projected in the right places, and essentially that's parabolic shaped, okay, and that's at the focus, okay, so that's kind of an idea there. You then also have the directrix, which is a fixed line. Your directrix and your focus are the same distance when you come to your vertex here, okay, where the parabola makes its sharpest turn, located halfway between the focus and directrix. If you come halfway between there, you're going to find your directrix and your focus off to the side there. If I find any point, so if I pick a point on this parabola right here, okay, the distance to the focus, this distance, and the distance to the directrix, remember from a point to a line, distance is perpendicular, those two distances are congruent. And you can do that with any point on that parabola. Okay? That is how this is formed. So it seems kind of weird, but that's what it is. You can pick any point on the parabola, and the distance to the focus and the distance to the directrix at a right angle are going to be congruent to each other. Okay? It's kind of weird how it works, but that is exactly how this works, and it's all of those points. Your axis of symmetry goes through the focus perpendicular to the directrix, but you should notice, essentially the idea there is know that it is symmetrical. Okay? A parabola is symmetrical. It doesn't just look like it is, but it is symmetrical. And we've already talked about our vertex. Again, our vertex is that point right there. This point. Okay, do we get the general words and understanding of a parabola here? Any questions on that? Okay, so then the next piece that you guys see, I'm going to skip that for now. We might come back to it. The next piece that you see is now that you know how it... hold on a second. I think I took out some slides and didn't take them out in here. Yeah, I did. Okay. The standard that we're going to do is derive the equation of a parabola given a focus and a directrix. So the next slide that you see here is this one here. Sorry, I don't know. I didn't take them out of there. You see your equations, you see a second equation, you see a vertex, an axis of symmetry, a focus, a directrix, and a description. You do not have to memorize this. Why is this open notes? Because you need to be able to look at this chart. Okay? So if we go back, and I keep referring back to that quiz page that I gave you guys. If we go back to that quiz page, it says that number 4, you're going to derive the equation of the parabola from the distance formula. We're going to cover that today. Okay? And it says that you're going to circle the equation in standard form for the parabola whose graph is shown. And it says you're going to be given a focus and a directrix and a direction. Okay? So if we look at this, if you're given a focus, depending on if it's a 0, p or a p, 0, that's going to tell you, okay, which direction your parabola opens up, okay, or opens. So does it open up or down, like this one, or like this one, or does it open right or left, okay, like this one, or one that would go that way. But based on giving a focus and a directrix, you're going to be able to tell. If your directrix is x equals, that's a vertical line, and so it's going to open right or left. If your directrix is y equals, that's a horizontal line, and it's going to open up or down. Again, you don't have to memorize this stuff. I'm just pointing out some of the characteristics that you're seeing. Okay? You're going to have this chart. If you want to, you can highlight this whole page, but this chart's here. When you see parabola, you're going to go back and look at it. Okay? Focus, directrix, and direction. So if you're given all of these pieces, you should be able to tell kind of which way it opens, which one I'm going to use. If I have the directrix given to me, it's giving me my p-value. Okay? I can fill my p-value in back here from one of these two equations, and I can write the equation, and that's all it asks you to do. Okay? Is circle the equation that is correct for this one. Okay? So let's do our first derivation here. Okay? Derive the equation of the parabola with vertex not at 0, 0. Okay, vertex not at 0, 0. If I keep the right papers in front of me here. Okay, so our definition for a parabola is a curve where any point is an equal distance from the focus and the directrix. Okay, so what we're going to do is we're going to derive, and I'm going to draw a picture here, we're going to derive an equation, and the equation is going to be the distance from the focus to any point, which is equal to the distance from the directrix to any point. Okay, that's how we're going to derive this equation from the definition. Again, the definition says a curve where any point is an equal distance from the focus and the directrix. So we do distance from the focus to any point is equal to the distance from the directrix to any point. Okay. If we start working through that, and it says the vertex is not at 0, 0, then I'm going to put a point in over here, and I'm just going to kind of draw in a parabola. General idea there. Okay. What letters did we use for the center of a circle? Center of your circle was what? HK. We're going to use HK for the vertex here. So the center of a circle is similar to the vertex in your parabolas, your ellipses, your hyperbolas, that kind of stuff. So your vertex here is going to be H comma K. It's not at 0, 0. Your focus, which is going to be somewhere in here. I don't care where you necessarily put it as long as it's within the parabola. Okay? Your focus is going to be at the same x value as this point here, so it's going to be at h, comma, it's going to be at k plus p in this case. Now, p represents the distance between that focus and the vertex. Okay? The distance between the focus and the vertex. Which is also the same as the distance between the vertex and the directrix. So wherever the directrix is, again, I'm just sketching a drawing in here, but if this is my directrix, the distance between HK and this line here is also p units. Okay? Is that line a y equals or an x equals line? If it's horizontal, y equals or x equals? Y equals, okay? This line right here is y equals. Okay? Anybody have any idea what it's going to be in variables? I know that it is p units below this point right here. So it's y equals what?
The line is p units below.
P units below the vertex. Below this point here. Yeah?
K minus P.
Good. It's going to be y equals k, the y value of this, minus p. I don't actually know if this line is above or below the axis right now. I'm just kind of giving myself a sketch so I can fill these in. Okay? I've got variables filled in so I can kind of see how things are going there. The last thing that I need, so I need my focus, I need my directrix, which I have both of those filled in, and I need any point on the parabola. So if I pick any random point on that parabola, what did I call those when we were dealing with circles? What can represent any point on the parabola? Represented any point on the circle. Make you think back. What did we call it? Don't think too hard, it's pretty easy, but what usually represents any point? If you want to give me a point, represents it. Yes, x, y, that's all it is. Okay? So x, y is going to represent that any point. Okay, so what we know by definition is that the distance from the focus to any point, so this is my any point right there, that distance is the same, and obviously I didn't draw this to scale, as the distance between that point and the directrix. okay, at a right angle to the bottom. What I need to know right now is what this point is right here. Does anybody have an idea of the x and y value, or the x or the y value of that? Yeah.
X comma k minus p.
Good. Okay, it is x because it's in line with this point up here, xy. Okay, so it's over just as much as the xy point is. Okay, it's up or down at this line right here, so the y value is k minus p. Okay. Now, those 3 points are what we're going to use to do some distance formulas here. Okay? This is about as complicated as these get because there's no numbers put in. We put all variables into this one. Okay? And so it's saying, can I derive the formula? So can I take this idea here and get to a formula? So this is our algebra step. Okay? Distance formula right here, which you can still think as Pythagorean theorem. Okay? I'm going to put it in as distance formula, but you're essentially doing the same thing here. Remember, it's a squared plus b squared equal to c squared, so you take the square root of both sides, and you do a squared plus b squared. So run squared plus rise squared. I'm doing the distance from the focus to any point, so I'm first of all doing this distance here. Okay? So my x and my h are separated. I'm going to write x minus h quantity squared. That's a squared. You can write h minus x. Again, it is in your best interest to put your x first. Plus, the second one is the difference between the y's. Now, here's where it gets tricky. I want to put the y first. If I want to do y minus k plus p, I cannot write that right there. Okay? I want to do y minus the quantity of k plus p, which makes this y minus k minus p. We have questions there. Here's your first little algebra thing. You may want to make yourself a note to it. Okay? That people will mess that up. So it's y minus the quantity of that. So in here I'm going to do y minus k minus p quantity squared. Okay? That formula right there represents the distance between the focus and any point on the parabola. Again, xy just representing any point on the parabola. Okay, so then we have to do distance between the directrix and any point on the parabola. Okay, so again, same thing. This is equal to, we're going to do a distance formula, so we're going to do square root. Instead of doing c squared, we're just doing the c, so you square root the other side. Okay, difference between the x's. Well, this is fun. Okay, these are my 2 points, the point on the directrix and the point on the parabola. So x and x, it's just x minus x, quantity squared. So that's my a squared. Yes?
Is the next one k minus p minus y?
Okay, you want to do your y first.
Oh, so it'd be y minus parentheses k minus p?
Okay, I'm going to do that over here just because it gets really confusing otherwise. So if we're doing this, what does that simplify to?
Y minus k plus p.
Good. Okay, so we get y minus k plus p. Right here you can show yourself and give yourself a little arrow to each of these if you need to so that you can kind of see them as to what they are, or write that as one step and then write what I did as the next step. Okay? But you're going to do that squared. Don't forget your square on that. Okay. Now, the setup is there. We have the definition, again, to say it again, a curve where any point is at equal distance from the focus and the directrix. So this represents the distance between any point in the focus and the distance between any point in the directrix, and they're equal to each other. Okay? Now, the question is, does it have to be that crazy? No, it doesn't. We can make it in a simpler form. Okay, so we're going to solve this. If you look at this equation, what are your thoughts on the first thing you can do, algebra-wise?
Square.
You're going to square both sides. Okay, now I'm going to write this here because you guys are going to look back at your notes and wonder what in the world you did. But the first thing you're going to do is square both sides. Okay, so I'm going to put a square on each of those, and I'm squaring both sides. That doesn't do much. It just simply rewrite the problem without the square roots. But that's exactly what you want to start with. You square both sides. Anybody notice something else that's pretty easy to deal with? Yeah.
The x and the x, you can just have 0 squared, which is just 0, take it out.
Good. So x minus x is 0. 0 squared is 0. 0 plus anything doesn't affect it. So essentially right here we can take this away. And again, if you want to write yourself notes as you go. Okay? We know that x minus x squared is equal to 0, so that can be removed. So I can just rewrite this problem without that in the problem. Problem's already gotten a little bit shorter. Now, the next step in this one, if I didn't show it to you, yeah, some of you would figure it out, but I'm going to help out with some stuff. Is hopefully you notice that on the left side and on the right side we have these two terms that look like they're going to cancel out in some way, but they don't quite. Okay? This one right here, there's no h's in any of this. It's not going to cancel out, so I'm not going to multiply this one out. But I am going to square each of these terms. This is where your algebra comes in. Okay? You've got to square correctly. When you square a term, you do this times itself. So you do the first term times the first term times the second, the first term times the third, then the second term times the first times the second times the third, and then the third term times the first times the second times the third. Okay? If you need to, you can write it out and show that you're doing y minus k minus p times y minus k minus p. You're multiplying those out, and over here you're going to do y minus k plus p times y minus k plus p. Okay? That's what we're doing here, is we're multiplying each of those steps out. So these are kind of my wording steps in the middle that's kind of showing what I'm doing here. Not going to touch this one. Could I multiply it out? Yes, it's not going to help me. So I'm just helping you guys out there. Okay? So that's going to say is x minus h squared. Okay? Then plus. I've got to multiply through here. Okay? So when I multiply through, I'm going to take y times y, that's y squared. Y times negative k is negative ky. My variable in this one is really the x and the y. So usually if you write a number, you don't write x2, you write 2x. So that's why I'm putting the letters in the front other than the y and the x. Okay, so minus ky, multiply the y by the negative p, so that's negative py. Okay, multiply the first one by everything, multiply the second one by everything. So negative k times y is negative ky. Negative k times negative k is a positive k squared. Yes, this algebra is a little bit long here. Negative k times negative p is a positive, and now you just have to decide p, k, kp, whatever. Usually I go alphabetical order at that point because they're both constants here. So plus kp. And then multiply the negative p by everything. So negative p times y is a negative py. And you're noticing this is getting nice and long, but it's going to be that way. Negative p times negative k is a positive, have I done that, kp? We want to keep them in the same order if we can, whatever you write. And then negative p times negative p is a positive p squared. I'm just going to use a little bit of room right below it. My equal sign is still there. Right here I'm going to do this one. It's very similar. What's the difference? It's a plus p instead of a minus p, so it's almost going to be the exact same stuff. And that's why we're going to be able to cancel some stuff out here in just a little bit. Okay? So let's see what we can do. And I actually do, just because I ran out of room here doesn't mean that I wouldn't do this normally. I would actually move these down normally, because we're going to cancel a lot of stuff out, and a lot of it's just going to line up with each other. Okay? So, I do my y times my y, which is y squared. Okay, my y times my negative k is negative ky. Y times p is plus py. And negative k times y is negative ky. Negative k times negative k is plus k squared. Negative k times p is negative kp. And then your p times everything, so p times y is plus py. P times negative k is negative kp. And p times p is plus p squared. Give you a second to catch up. Again, this is all about some algebra right now. Okay, we've done the geometry part and it's derived the equation. So we've got some algebra that's built into our geometry here. Okay, we're deriving the equation. Remember that these two equations are on opposite sides of the equal sign, so we are not adding them together right now. What we can do is anything that's the same on both sides of the equal sign we can cancel out. Okay, so what I'm going to do now is I'm going to cancel like terms on both sides. Okay, canceling like terms that are on both sides of the equation. So y squared and y squared are on both sides. Negative ky are on both sides. The py is a negative and a positive. Those do not cancel. Okay? Negative ky cancels again. Positive k squared cancels. The kp does not cancel. The py's do not cancel. The kp does not cancel. The p squared cancels. Okay, so you can cancel what they have in common on each side. And then we're going to simplify. So you're canceling like terms and then simplifying. kind of all in one step here. So this x, I'm just going to work my way through this and simplify as I go. Okay, x minus h squared, we know we're just kind of bringing along for the ride. So x minus h squared. Okay, look through here. I have a negative py. As soon as I see that, I want to see are there any like terms with it. There's another negative py there. So that means it's a negative 2 py. Remember when you add variables together, x plus x is 2x. Okay, it's not squared. We're adding those together. I keep going on. I have a kp. I also have another kp. So I have a plus 2 kp. Then I run into my equal sign. Okay, keep going. I'm on the green here. I work around. I have a py right here, and I have another positive py right there. So I have a plus 2 py. And then lastly, I have a negative kp and a negative kp, which means a negative 2 kp. So we've gone from this, we squared both sides, we've canceled out that x minus x squared, we distributed just between the two trinomials. Okay, we've got a lot of stuff. Canceled like terms, simplified, and we're to this point now. Okay. So we go from this, and we're going to keep x minus h squared on one side, and we're going to move everything else to the other side. Because if you notice here, this py and this py, this kp and this kp are like terms. We're going to put them together. And I'm telling you now, we're going to move them to the right side. Okay? So we're going to combine like terms here as well. That one was cancel like terms. Here we're going to combine like terms by moving them to the other side. Move the board up here a second. There it goes. Okay. There you go. Okay, so combine like terms. Add 2py to the other side, so I'm adding that 2py. Add 2py, that cancels those out. Subtract 2kp, subtract 2kp. Again, these are canceling over here. I'm going to have just x minus h squared on this side, equal to, and then combine these. You're going to see that it's 4py minus 4kp. And then one last step. And one last step is to factor out your like term here. So on your right side, 4py minus 4kp, what's in common? What can you factor out? 4p, good. You can factor out a 4p. What's left over? Good. Y minus k is correct. And that's equal to this x minus h quantity squared. So if you look to the bottom left of that box that you guys are in on your notes, you should hopefully see that exact same equation in that top box. So the equation does not come from nowhere. Okay, we just showed where it came from, and it comes from the definition of a parabola. Okay, so you see x minus h quantity squared equal to 4p times y minus k. So I'll have students in the past that ask me, and they're like, where's the 4 come from? There's your answer right there. I can't like say it's from this one thing. It's from the derivation of the equation. Okay? It's not like it's because a parabola is 4 times anything like that. You can't answer it that way. Okay? But this is how the equation is set up. Okay? So what that takes us to is that next chart that's on your page. And again, this is that equation we just found. Okay? And it shows your equations. Your vertex is now not at 0, 0. So the difference between the two charts, the first chart, the vertex was at 0, 0. Okay? So if you want to make a note to yourself, that first chart is if the vertex is at 0, 0. This is vertex can be anywhere. And you can use this chart if the vertex is at 0, 0. It works out the same. Okay? Vertical or horizontal axis symmetry, you've got your focus, your directrix, your description, based on how they come. We dealt with this first focus and directrix. We showed where that came from. If I turned my parabola sideways, I put my vertex down, it's still hk. I know that the distance between that and the focus is p. Okay? So the x value is the one that I add the p onto. Okay? The x value is the one that I subtract the p from to find the directrix equation. It's all the same process as what I did on that first problem. Okay, again, I'm trying to give you guys some examples. These are longer examples, so we don't do a ton, but we're going to do a few here. This one's going to be easier because you're given numbers. You don't have as many letters. Okay? So we're going to go through and we're going to do this one. It says derive the equation of the parabola of focus 3, 5 and vertex 3, 1. Okay? We're going to go through and derive this one. I'm going to first start with a drawing of it. So focus is at 3, 5. So I'm going to go to 3, approximately 5, and I'm going to put a point. And I'm going to label that as F just so I know that's my focus. Okay? Vertex is at 3, 1, so I'm going to go to 3, 1, and I'm going to put a vertex. I'm going to put a V just so I know that's my vertex. Just with that information, you should have an idea of what your parabola looks like. Okay? We're not going to do specific graphing of it. We need to know the general idea. If my focus is here, imagine the flashlight. Okay? Remember, your flashlight's got a curved shape to it, and that light's in the middle. This is my focus. This has to be my flashlight here. So it's going to have a curved shape, something like that. What's your P value? What is your P value here? Yes?
4.
Why?
Because P is equal to the distance between the focus and the vertex.
Perfect. Distance between the focus and the vertex is your P, and your P in this case is 4. Okay? So we can find our P value. Where is my directrix at then? Yes? Perfect. Y equals -3. It's going to be a line that is horizontal. It can't be vertical because it's always going to be on the other side of the parabola from the focus. Okay, it's going to be a horizontal, which is y equals, and you take from this point, the y value of it at 1, and you subtract the 4, we're going down 4, and you get y equals -3. So in that case, if I'm going to derive this equation, the other two things I need is I need a point on the parabola, any point, and you can put it anywhere you want, so let's throw it over here this time. It's still xy. Right? We know that the distance between that point and the focus, which remember the focus was at 3, 5, so I'm going to fill that in. Okay? And that point and the directrix. Did I draw this to scale? No, how do we know right now?
Because those two look congruent.
Those two distances don't look congruent. Do we all understand that? Okay? What that's showing me, just because you guys probably don't have this idea, is that my parabola would open up more. It'd be something like this, because that's going to make this distance and this distance congruent. Okay? So I don't care if you draw them to scale. I just want you to be aware of that. Is that the parabola would open up a lot quicker, and that it would be congruent. Okay? We want these two to be congruent, though. What is that point right there on the directrix? Point on the directrix, what is it? One variable, one number here. Yeah, Amanda?
X -3.
Good, you got it. Okay, x -3. It's left or right in line with this point, and it's up or down in line with this line. Okay? So those are my points. So what do I do to derive the equation? Well, I take, again, and I've repeated this multiple times, but I take the definition. A curve where any point is at equal distance from the focus and the directrix. Okay? A curve where any point, this distance and this distance are equal. Okay, so I'm going to do the distance to the focus first. Okay? Distance formula for my focus. It gets a little bit easier here. Okay? Remember, it's the x's subtracted and squared, so it's the run squared. So it's x -3 in this case squared. Okay? Plus, it's the b squared, which is the rise squared, so it's the y values. So in this case, it's y -5 squared. That's my distance to my focus. Equal to, we want to do the distance to our directrix. So that's going to be between xy and x -3. So it's going to be the square root of, subtract the x's in square. So x minus x quantity squared. Plus, subtract the y's in square. How am I going to write this one? A little bit of a trick in here. Good, y plus 3. Okay, y minus -3 is what I'm going to have to do. So that's y plus 3 quantity squared. Already you should look at this and think, okay, that's easier because you don't have this k minus p and p minus k and all that kind of stuff in there. Okay, so you don't have as much to deal with. But we solve it the same way. So what I want you to do is kind of look back and forth as we go. So what do we do first? We square each side. We're going to do the same thing here. Okay, so we're going to square each side. Square both of these. I'm just going to rewrite it, and I'm actually going to do 2 steps at once here. I'm squaring that side, and remember what happened with that x minus x squared? Just goes away, right? So I'm just going to take it away, in this one step because we should be able to do both of those at the same time. Okay. The next thing we did was we multiplied out our terms. Okay. In this one, it's going to be the two y terms, not the x term. Find the two that have something in common with each other. So it's these ones here. It's not the 3 and the 3. Okay. The variables are the things that we need to get rid of. So I'm going to multiply this out. That means I'm going to do y minus 5 times y minus 5. And I'm going to do y plus 3 times y plus 3. Now, some of you are better at this than others. You can take your shortcuts if you want to here. Your x minus 3 does not need to be multiplied out. Okay? Plus, here, some of you know it's y times y is y squared. And then you can do y times negative 5 and negative 5 times y. Those combine to make negative 10y. If you want to do it as two separate steps, you can. And then negative 5 times negative 5 is positive 25. Equal to, do the same thing here. Y times y is y squared. Y times 3 is 3y, 3 times y is 3y. Put those together. Okay, so 3 plus 3 is 6, a positive 6y. And 3 times 3 is 9, so plus 9. You can take an extra step in there if you need to. Okay, there's nothing wrong with that if you need to take an extra step in there. Cancel out terms on either side that are like. So we have y squared and y squared that are like here. I didn't put one on top of the other because it's not as complicated as the other one. I'm not saying it's easy, but it's not as complicated as the other one. Okay? And then move all of your terms to the right side. So I'm going to change colors here so you can see it. But I'm going to take, except for my x minus 3 squared, I'm going to take and add my 10y to the other side, and I'm going to subtract 25 from the other side so that these cancel here. That gives me x minus 3 quantity squared equal to, follow it through, I'm going to get 16y minus, and in this case it's going to be 16 there. What was our last step on the last one? Factor out. What do you factor out here? 16. Good. So I'm going to have x minus 3 quantity squared equal to 16. What's left over? Good. Y minus 1. Don't forget that minus 1. Okay? And that would be your formula. If you went back to the chart and you looked at the chart and tried to find this formula, given the p-value that we knew of 4, given the focus, given the directrix, you'd be able to write that equation. Okay? You would go, so look at that chart for me. Okay? You would go into the chart and you'd say, okay, I drew my picture, it faces up. So I go to the very end of the chart. Direction up is the top line of the chart. So I know I'm going to write it in the form x minus h squared plus 4 p times y minus k. Okay? H and k, what are they? Well, the center of this one, vertex of this one was at 3, 1. So there's my h and my k. Okay? And then the p-value for p, my p-value can come from, I found the difference between the focus and the center, so that was 4. 4 times 4 is 16. Okay? So you can fill those in. We just derived the equation. That's how you can just write the equation if you're not asked to derive. Okay? So the last piece of the puzzle here is, maybe, the last piece of the puzzle here is we've just covered deriving the equation. Now we have to talk about give the equation in standard form if you're given certain things. Okay? So, for instance, here's a very specific equation. Notice that there's no minuses or pluses in this one. Okay? So that means the center, or the vertex, is going to be at 0, 0. We have to have that minus or plus to change the vertex. Okay? If you look at your two charts, that's kind of the difference between the two charts, is that minus and that plus. So our vertex here is going to be at 0, 0. Okay? You look at this and try to match it up with the chart. Okay? And so I know you're flipping back and forth, but you're matching this up with the chart. You're looking at the chart, the one at 0, 0, and you're trying to figure out. The easiest thing to do is look for your x squared. This is an x squared. Look for your x squared in your chart. So that's on equation 2 on the top of the chart. That means that this can either open up or it can open down if I go to the far right of your chart. Okay? It either opens up or it opens down. This one is going to open up. Why? What's the difference between up and down, does it say there? No. That's up and down versus right and left. If you look at up and down on the far right of that chart, what's the difference between it? A p is either positive or negative, right? Okay? In this case, we don't have any negatives, so our p is going to be positive. So this one opens up. Okay? So that's what you're looking at. You're looking at the chart. You're looking at your x squared. You're going from there. P value in here is you can look at your chart and you can see it's x squared equals 4py. if that's the equation, and I want this to match up with this, well, the x squareds match up, okay? The y's match up. That means the 8 has to match up with the 4p. What does that make p equal to? 2, okay? So I have a p-value of 2, positive 2. Then it says, what is the focal point? So if my vertex was at 0, 0, my focus is at, going up 2 from that. 0, 2, okay, so my vertex we were talking about was at 0, 0. I'm going to go up 2 from that, so it's going to be at 0, 2. You can graph it or you can write it first. Okay, this is, I guess I can label these. This is my focus, this is my vertex. Okay, what is the equation of the directrix? So I look at my chart. Directrix says y equals negative p. Okay, it says y equals negative p. I know my p-value to be 2, so my equation is y equals negative 2. Okay, just use your p-value. That's all you're doing in these ones. There's y equals negative 2. That's my directrix. Okay, how would you graph it from there? You determine some points. You do this, just pick some random x values, and you just fill them into the equation. So I did this part for you. You can plug them back in some other time. But this is 4.5, 2, 0, 2, and 4.5. Okay, you can fill in more of them, but it essentially gives you the general idea of that parabola, that it opens out further. Okay, and sketch the curve through those points. So, there's a lot you guys are going to be working on tonight. Again, I'm going to post this video. Feel free to go watch it. Okay, there's a lot that just went on today. Look at your notes, highlight whatever you need to on it. But that's kind of essentially the idea of our parabolas. Okay, let me know if you guys have questions, but you do have homework to do as well.